Okay, today we're going to be looking at square root functions. So this is going to be an equation that contains a square root. And we're going to be talking about the fact that our independent variable is going to be in the radicand. So when we say radicand, that means underneath the square root sign. So when I'm talking about what is underneath the square root, and that's how we are going to be solving, is by looking at the radicand to determine our domain. So it's really important to understand that when we have a square root, we cannot take the square root of a negative number. That is not a real value that exists. So when we're looking at our equation, our radicand, our value underneath the square root, has to be greater than or equal to 0. And so that will help us find out what values of x are possible for this equation. We call that the domain. Okay, so we're looking here at our equation, and we want to find the domain. So again, the domain is going to center around where our independent variable is, and that's our x value, and it's underneath the square root sign. So we need to make sure that everything underneath the square root, that's called our radicand, so x minus 5, that has to be greater than or equal to 0. We can't have a negative underneath a square root, then that wouldn't be a real solution. So we're going to find out what our domain is by setting our radicand greater than or equal to 0. So we're going to add 5 to both sides, and so we get x is greater than or equal to 5. So that means that our domain is the set of real numbers greater than or equal to 5. Okay, so we're going to look at this, and we're going to be describing the domain and the range. And so we're going to do a couple things. We're going to actually go ahead and graph this by making a table of values. Then we're going to look at the radicand. Again, the radicand is going to tell us what our domain is. And then looking at the graph, we're going to be able to find our range. So we're going to start with our domain. And so we look at our radicand of x, and we know that x has to be greater than or equal to 0. There's nothing to solve there. That would be for the base function. We're going to see how that translates when we add 3. But it's going to have the same domain, because notice the radicand of our base graph is the same as our radicand of our y equals the square root of x plus 3. And then we're going to compare them. So they both have the same domain. Now, what is going to be different is the range. So we're going to go ahead and make a table of values for each graph, and then we're going to go ahead and graph them. So we'll start with our first equation, y equals the square root of x plus 3. So we're going to look at our x values and our y values. Now for x, I'm going to pick perfect squares. It's just going to make life easier. I know that I can start at 0. So the square root of 0 is 0, plus 3 is 3. The square root of 1 is 1, plus 3 is 4. Then I'm going to skip ahead to my next perfect square, otherwise I'd get decimal values. The square root of 4 is 2, and 2 plus 3 is 5. All right, now I'm going to compare that to our base graph, which is y equals the square root of x. So I'm going to use the same numbers for my x values because I know they have the same domain, but I'm going to get a different y value. So 0, 0, 1, 1, 4, 2. And now we're going to compare their graphs. So if I'm graphing, I'm going to graph my first equation, which is the plus 3. So I graph 0, 3. I graph 1, 4. I graph 4, 5. I can see my graph has a very slight curve, and it's starting to kind of even out there. All right, now I'm going to graph my other equation, 0, 0. This one's at the origin, 1, 1, and 2, 4. I'm sorry, 4, 2. So we can tell that the graphs look identical. The only difference is that the black graph has been translated up 3 units, and we can see that in our equation right here. So this one would have a range of y is greater than or equal to 3, whereas our purple graph starts down here at the origin. So this one would have a range of y is greater than or equal to 0. So they have the same domain, but different ranges. Okay, now we're going to do the same thing. We're going to do a second graph. I'm going to start with my domains. This time the graphs are going to have different domains. So if I'm looking here at my first equation, I'm going to find the domain and the range. So my domain, again, I take my radicand. X minus 2 has to be greater than or equal to 0. So I add 2. So x is greater than or equal to 2 is my domain. Now, if I look at my domain of my root graph, y equals the square root of x. My radicand is x, so x has to be greater than or equal to 0. That's my domain. So I can already see they have a different domain, so it appears the red graph is going to be shifted over to the right 2 units. Notice that that 2 is underneath the radical versus when it was outside the radical, that shifted it up. There's another thing happening here that's very interesting, and that's this negative. So when we make our table of values and when we graph, we're going to see how that changes the graph. So I'm going to start with my table of values for my red graph. So y equals the opposite of x minus 2. And I'm going to be strategic again with what numbers I choose. I'm going to start with 2. So 2 minus 2 is 0. The opposite of 0 is 0. Now I want a perfect square, so I'm going to do 6 because 6 minus 2 is 4. The square root of 4 is 2. And the opposite of 2 is negative 2. And then I'm going to choose 11. 11 minus 2 is 9. The square root of 9 is 3. And the opposite of 3 is negative 3. I'm going to do the same thing over here to find my table of values, my x and my y. This time I'm just going to plug in. It's going to be the same as what we just graphed. So we'll have 0, 0. We'll have 1, 1. We'll have 4, 2. Oops, you know what? I'm going to have some negative values here for y, so let me adjust my graph a little bit so I can have both the positives and the negatives. Okay, so I'm going to graph my red graph. So I have 2, 0. Then I have 6, negative 2. And then I have 11, negative 3. I can see my graph is kind of going like, oops, I think I made that point just a little bit too low. Let's make it a little bit higher. 11, negative 3. I can see my graph doing this shape. So almost like it was flipped across the x-axis, we would call that reflected. And then, of course, this one is 0, 0, 1, 1, 4, 2. So we can see that the red graph has been translated to the right and then reflected across the x-axis. So this red graph is to the right 2 units, and then it was flipped, so we call that reflected across the x-axis. So we're just comparing the graphs here.